uh, as our final week is about testing and debugging. Okay, what do I mean by testing and debugging? Actually, we are going, as you know, it's the last stage. It means like you made some product, you made some software, and now you want to evaluate the software. So this week we are going about to testing and debugging what you have made in anything. Contents that we are going to cover. First, I will say what is a quality software. Then, what is testing? What is debugging? And different types of testing. And then I will go more about unit testing, which is one of the testing types. Okay, so you know, when we want to test something, anything in life, even for example, you might tell me, I'm a football player, right? And I'm going to say, okay, if you are a football player, for example, play a while in this field or work with, I don't know, this football field, and I see how can you manage a ball or something like that. So it's actually uh, testing a software, testing something for qualification to understand. Let's talk about software level. We want to see this software that we have made, that it is bug free, and it is let's say a quality software is bug free. It means like it's working fine, it delivered at the right time with right budget and meets the requirements and expectation that it promises. So actually it means it works. Let's make it simple, it works as it says, right? You have an operating system, okay, it works as it says, it's work fine. So a quality software, uh, there are, let's say, there are some standard level. I just put it here, and it has a number. So we have an ISO that defines that this software is the totality of features and characteristics of a product or a service that bears its ability to satisfy stated or implied needs. So basically, we want to make a software which satisfy customers or I don't know, everyone that we are going to offer this software to. So what are the key aspects that a customers might need? For example, okay, it have to be good design. I know definitely by your own logic, you basically understand most of it. It should have good design, good functionality. It should be reliable, durable, and also it has a good value for the money. So basically, as I said, it should be qualified for the customer. So we have a definition that we have a software which is qualified for customers. So how can we understand if it's qualified or no? We have to test these things. You say, I know English. I say, okay, have this IELTS exam. You say, I know German. And I say, okay, have this German exam. So basically, we are going to test our software. So software testing basically is process of executing a program or software to find software bugs. So, you know, by bug, well, technically, I assume all of you know what do I mean by bug. It means, for example, the part of your programs that are not working properly. We have even some people like their job is tester. Even it's really demanding actually. You can even in Czech Republic you can find many jobs titled software testers, and you can be paid to only be a software tester. So I made a photo here. So developer actually makes a software and tester tests it. So as much as tester finds a bug, it says to the developer, okay, you have a bug, and manager, of course, doesn't want bugs to be in the software. So testing a software makes it sure that our software is meets all the promised features, right? And can be implemented with the same characteristics it's already said. Okay, so we have a software testing. Then there is another word called debugging. Okay, so let me tell you something in parentheses. In this presentation, at first, I'm going to talk about software engineering concepts, like what is debugging, what is testing, what type of testing we have, what is quality software, as I already said, and then I will shift to the some practical word and some tools for it. So it's combination of let's say this week is combination of software development tools and software engineering. So prepare to see and to hear some theoretical concepts like this. For example, what is debugging? Okay, debugging is a multi-step process. Many of you already heard it because you're working with Visual Studio. I'm assuming that it means like debugging is like uh, make your program, make your software in multiple steps and go through it, each level, each line to find if your code has the error or no. Okay, so debugging actually means like finding those bugs in your codes. So basically, some of you might ask and question now, okay, why I'm making this so long, and and basically debug is debug, and you see what is wrong in your code. I say yes, but it's because now you are assuming a small project, so like a project which all the program is just one file of C sharp, let's say. But when projects gets big, when project gets millions of lines and hundreds and thousands of lines, now it will be difficult for you to go to each line separately and go to each line separately. So that's why there are some other tools will come and will become handy in big companies and in real project. That's why it's important for you to understand debugging at the standard scale, not only just what button that you press. So we will have something called unit tests when the project is getting big. I will explain it completely later. Code review, pair programming. For example, pair programming means when you are working with a colleague on the same project and your friend is reviewing your code and finds something that you cannot see. So my aim is to make you able to understand how to debug your projects when they are getting big in real life, which is not just one file and one source and one Visual Studio. So the concepts I was talking about, one of them is software verification. I try to not make them so long. Software verification actually is like uh, when you are making a software, while you are making a software, it makes sure that you are doing it right. Imagine this question: am I building this product right? So during your development, software verification is the term that evaluates that your project is building in a right way. So that's software. If you heard what is software verification, it means like you are verifying while you are progressing that your software is being made in a right way. So let's go to software validation. So we have two terms: software verification, software validation. What's the difference? Software validation, it means, okay, I made a software, I made something. Is it is it the right product for my customer? Let's say I give it example like cooking. Let's say you have some guests and you are cooking something, and let's say your mother, your father, or a friend who is like a good cook is supervising you in kitchen and says, and you are saying, okay, add this, and he says, add this, add that, add this. So you, and he makes sure that you are making it right. Okay, and now you made it and you offer it to your guests. That is it what your guest wanted? Is it a valid food? Is it the right product for the needs of your customers, which is, let's say, needed something, and is it the right product? So it's usually at the end of the progress that what you have done, is valid. So I know some of you might ask, okay, they are like theoretical terms, but these are things that you might hear in real projects: software verification and software validation. So what is a software testing life cycle looks like? It usually has 6 steps. Other people, of course, they might have different types of, let's say, presenting a life cycle, but this is the common normal way. So basically, it's a sequence of activities that makes sure your testing, you make sure your software uh, meets the promised goals that it promised. So it verifies and validates the activities. Let me make it simple. So we have basically 6 major phases. You can show it that it's like the order of the phases, and I will explain them briefly. What do I mean by each of them? So requirement analysis, you can by your logic understand. For example, when you have a customer that it says, your customer said, I need this kind of, like, let's say, these kind of qualities in the software. I need these, that, these, this. So, and this is a document that have to be fulfilled. Okay. So at first you analyze what should I make? What are the requirements? So this is basically requirement analysis. So for this requirement, you need to plan some tests, and you have to make some strategy. And so the test teams make some plan and strategy for this approach. Then test case designing. What do I mean by that? Okay, you design some test scenarios, that these test scenarios are things that might be happen in real life, so you want to test it before. So you say, for example, a student might go and click on this button and that. So let's design such an experiment and see what will be happen if users do that. So we have some test cases. Test environment setup. Basically, yes, your software is going to be in an environment, right? By environment, for example, it might be in mobile device, it might be in a company or somewhere with special platform. You test that environment as well. Okay, then uh, then test execution. You run all the tests, and you want to design you want to find the bugs and defects and so on. Then test closure means now you done your test, you have some analysis and some reports that, okay, my software works like this and like that under these situations. And then you decide, okay, how you have to fix this, or how you have to fix that. Okay, so testing methods. Let's talk about testing methods. So we have some defined methods that basically they might have some overlap with each other, but let's review them, that if you heard these terms in your real projects, in real companies, in real life, what people mean by that. We have static testing, we have dynamic testing, we have white box testing, we have black box testing, and we have visual GUI testing. Okay, some of them might have overlap with each other because they are concepts actually. For example, and I will explain them. Now you might wonder why I made these two like with different colors. Actually, these two are the most important concepts that I want you to know. Okay? Then I will briefly review these others, which these will be included in these as well. Okay? So static testing, dynamic testings, or some people say static analysis, dynamic analysis. I will explain all of them. Okay, static testing or static analysis. Okay, so let's talk about this. Basically, a static analysis is done before running your code. Now you might be wondered, okay, what do I mean by that? What do I mean like it runs before the code execution? Actually, let's say, what is a software? A software is lines of codes, right? Okay, so a static analysis actually means to analyze these codes that you have inside your project before making it. So it means like someone who is experienced, let's say, looks at your code and says, okay, for example, David, you put this variable wrong. It will makes a problem. Okay, you make this part wrong. You used memory here wrong. So it's like basically someone is reading your code before running, and says you are, by your code, he or she will understand that you made some mistakes and it can be fixed even before running. So actually, it's like basically someone reads your code and says this part and that part is wrong. So basically, you already see that your IDE, let's say your Visual Studio, before before even compiling, for example, makes some red lines under your code and says this part is wrong because you didn't clear that part, right? So technically, this is static testing. It means like uh, testing your code before even it's run. Okay, you might say, okay, but it's very obvious. I always check my code and so on. But as I said, in real projects, you will face a project that is millions of lines. It means here you might need some softwares, some tools that reads your code automatically for you and finds and give you suggestion. Okay, David, you made this variable wrong, and millions of line. Imagine if it's millions of line, if someone wants to read it for you, it's really time consuming. You see, uh, you know what let's say what we are looking for when we do static analysis. So basically we are looking at lines of code. We were looking, for example, if we had proper nesting, if we have comments frequently, if we have right and enough function calls, if cyclomatic complexity is not too high. You might say, oh, it's like very complex. No, I mean, just your software is not too complex. It's also checks for unit tests, and you will understand what is unit tests. So actually, we want we want to evaluate a code before it's being run to make sure that some of the problems might be stopped before even running. So basically, that's static analysis, and your reliability and your like reusability and other things, all other attributes that static analysis is focusing. So it's not complicated. Don't be afraid by these, let's say, definitions. Actually, basically, we want to prevent code from errors and bugs before it's run. Okay. Let's say, what are the advantages and disadvantages of static analysis? I will show you now. It might not be clear in your mind, but I will show you just right after the next slide. What do I mean by that? Okay. So what's advantages of static analysis? So it can find weaknesses at the code at the exact location. What do I mean by that? What do I mean? Because you are actually reading the codes. So you will see at this location, it might face a problem. It can even be done by a trained software. Imagine like you have a really good teammate and he or she can read your codes and see, okay, here I see some problems that might happen, and so on. Also, if you fix a problem before it happens, it's really faster. Assume that you, before running your code, someone says, hey, look at this line. this line will face a problem, rather than you running your code and it crashes, it not working, and you might think, okay, where is wrong? What is wrong? What is wrong? So it's faster if you know it before running it. So I don't want to go like very deep details to details. So I just want to say that what are the problems that might happen? For example, some part of your code might be unreachable. You might have some function that you are not using, right? So, but we want to know them before they are happening. Okay. What are the limitation of, let's say, static analysis? So it is time consuming if it's doing manually. Let's say you have a really long code and someone has to go through it line by line. It can be really time consuming. I told you that there are some tools that do them automatically for you, right? But as I said, they are not human. They might make false negative, false positive. They might say, okay, you have a problem here, but in reality, it's not, right? So, because a software will do it for you in big projects, so you might have some false negative, false positives. So, and also, it cannot understand the errors that are related to the environment. For example, your code is perfectly fine, but your environment is not matched with your code. What do I mean by that? Imagine, let's make it simple. For example, you have a game and it only works in Android 10, let's say, okay? And your code is perfectly fine. But and your software says, oh, your code is perfect, but this code cannot be run on Android 7, let's say. So it cannot detect the errors that are related to environment. It only looks at code. Uh, there are some tools. There are some tools that makes this automatic code, static code analysis for you. One of them is CPPCHECK. Okay, there is a software called CPPCHECK. I'm going to show you right now, and at first, I will explain briefly what is it. CPPCHECK is a free open source software. There are many softwares like that, but I am introducing this for you. And it do a static analysis for you on C and C++ programming language. And it finds, okay, don't scare by that. It finds some common errors that programmers will do, like memory leak, undefined classes, unused variables, and so on. So it usually for C and C++, for each program, even if you are using Python, if you are using, I don't know, C#, there are different tools. And good news for you who are C# developers is that Visual Studio has a code analysis in itself. So for C#, you don't even need CPPCHECK. If you are using C or C++, you need it. But if you're using Visual Studio and let's say C#, it automatically have it inside itself. So I understand now you might get bored by like theoretical part. So let's make it more fun and see these applications. So I will go to my browser and I will show you CPPCHECK. Basically it's really simple. You can just say download CPPCHECK. Okay, I write it wrong. And yeah, it's on SourceForge. And if you just write it in Google, you will be find it easily. And it has like online demo, like information, wiki, and so on. And you can install it for Windows, Linux, no matter, it's all the same. So I want to show you how it would be look like. Okay. Let me go to a project. At first, let me show you let's see a very big C++ project, because I want you to understand why we needed like a real software. So I show you a Vim. Vim is a editor that you can use, and it's open source. That's why I'm going to show you the project. I'm showing you its source. It is on GitHub and it's free. So let's go to the Vim and we will see how it's look like. this is the Vim project, and this is open source, so we can see the sources. You see, it is really big. It is really big. Like, it can be millions of lines. Okay, so let's see how CPP check works on Vim. And I will clone this project, which you already know how to. So I will go, let's say here, and I create a folder. Let's call it Vim. Okay, I will go inside, and let me, in practical, I will clone it so you can review it. Git clone and the link. So it will be cloned now. You see, it's quite huge, and not huge, not big. Let's say I think it should be about 100 of megabytes. So it's got it, and wait for it to be 100%. So done. Okay, now it's done. You see, in real life, you see these are all of them are codes. Let's just look one of them randomly. I want you to understand why we need tools. You see, one test, for example, one file is that big. Another file might be even bigger. For example, I don't know. Let's you see, imagine how difficult for you be to do static analysis. It means like read each of line. Okay, what's wrong? What's wrong? What's wrong? What's wrong? So it's really time consuming. That's why there are some software like CPPCheck. Let me run it. You can install it as on the website as I already showed to you, like CPPCheck. You can download it here, but I already downloaded. I run it for you. It's similar, the same on Windows and Linux. So you have something like that basically. Let's look how it's look like. Basically, it's very simple. It can even be integrated inside your, let's say, your IDE. For example, if you are using PyCharm, Visual Studio, or whatever, it can be included inside as a plugin as well. But I'm using it standalone, so you can see in real how it would be look like. So I create a new project, and let me go. What was the name we make? I think it was Vim. Yeah. Okay. And so I create a new project and I name something for the class. I save it. So I just make a new, and it says, okay, where is your source file? You can browse it if you're using Visual Studio. You can browse for the project like solution file. But if you don't have, like me, like here, you can simply add your source folder here. So let me add it. I will go, yeah, Vim, and source file. So I said my files are here, source file, choose it. Okay, then I say, okay. It says I have to create this directory. Would you let me create it? I say, okay, create it, no problem. And now it starts to analyze your code. Okay, as you see, for millions of lines, it's really, let's say, time consuming. Now it takes very long time. Just you see, now it's 181 file, and now it's only one file that it's being done. So it do a static analysis for you, and it might takes time for the big project. Let's see how it looks like for the things it's already done. You see, it shows you things here, and it says, you see here, you see the color here is different. It says here, okay, and what is the problem? It says, gives me suggestion that in a scope variable m here can be reduced, and warning, be careful, and so on. And it gives me some example that, for example, if your function is like that, I'm not going to talk about the programming. I'm just saying, according to the language you are using, it can give you suggestion. It says, for example, you are using your integer here, but you can put it inside the inside your, let's say, a scope, and it can be reduced your memory, let's say, or whatsoever. So it gives you actually that at this line, you see number of line, at this line, line 89, you can do this. Of course, these codes definitely have few problems because professional people are made it, and I cannot, let's say, just simply put errors on them. So they are basically, some of them might be even false negative. This software might say, okay, it has a problem, but actually it's not. Let's say, so in some cases, and in some cases it might be problem. So I just want you to show you that the software finds some places. For example, here it says the scope variable idx can be reduced, and finds in big projects, it will finds possible errors for you before running it. See, it's not even 1% because the project is huge. Imagine if you wanted to do it by your eye, it would be really time consuming. So now you see at least how it works. So let me stop it. So it's actually CPP check, right? So you can do work with it in C or C++, really huge if you have a huge project. And I just wanted to show you that side. Let me show you Visual Studio, how it would be look like in Visual Studio. Let's switch to Windows. Okay, I already loaded for you. I told you the good news for you is Visual Studio has such a thing inside itself, and it's called Analyze the Code. It will analyze the code for you that, okay, this part is right or this part is wrong. Okay, so for example, this is, I will talk about it at the end of the class, what is this going to be when I want to talk about unit tests. But I just want to show you how the static analysis of the Visual Studio works. For example, let me define a variable but not use it. Okay, so it means like I'm getting part of memory but I'm not using it. I put like int, let's say utb or whatever. So I define the variable, but I'm not using it, right? So I go to the analysis, and I run code analysis, and says run code analysis on this file. It can be even on your all solution, but just on this file. Let's see what Visual Studio will give us. Just give it a time. Give it a time a little bit. It's doing something. Okay, you see, it did analysis for me, and these are at the output window. You see the results, and it says, okay, it can be built successfully. But see here, it gives me a warning. It says utb unreferenced local variable. Okay, it means I have defined a variable, but I didn't assign anything to it. So actually, it's getting part of memory. I know, like this one small variable is not important, but I'm just showing you the concept. You might have even like many big errors. So this code analysis in Visual Studio do the static analysis for you. As you say this variable is useless here, or you have unreferenced local variable, let's say here. So basically on Visual Studio, you can use its own analysis, which is a static analysis. Okay, so that's about static analysis. You can use CPPCHECK, you can use Visual Studio's built-in, you can use different methods. There are many tools for static analysis. Some of them are paid, some of them are free, which I only showed you two of them. Okay, let's go back to the class. And so I talked about the static analysis. So now let's talk about the other important thing, which is dynamic testing. So by now, by your own logic, now you understand that I was talking something about before running your code. Now dynamic testing is running your code and see what is happening. So basically, it's actually what you are already doing, but now you know the term for it. So dynamic testing means like you run your code, unlike the static testing, which was analyzing the code. Here you are running the code and you see, okay, this part is not working fine. This part I'm getting an error. This part is like that. And the most common dynamic analysis practice is unit tests. I will talk about unit tests and I will show an example of unit tests for you. So basically by now I want you to understand that it is running your software and now see it in real practice that, okay, it has, for example, crashes, it has something like this. So advantages and limitation. Let's talk about advantages and limitation of the dynamic testings. So unlike static testings, which couldn't identify runtime environment errors because it's not actually running, here, for example, it might say, okay, this software not working on Android 7, this software not working on this particular operating system. So it's actually, it shows you the runtime environment errors. It also, let's talk about important parts. It's also gives you, like, it can validate static code analysis findings. For example, your static analysis says, okay, your code is good. Then you run it and you see, okay, if it is good or no. So if your program passed both static and dynamic testings, means it's actually a good software. Okay. And also, you might have even some false negatives in your static analysis. I mean, like sometimes a static analysis says your program is really good, but you test it in real life and you see, no, it's not really good. Okay, so it's actually verifies the previous step. And what are the limitations about it? So, you know, sometimes it's really time consuming to find what is the problem, because, for example, you run a program and you just see its crashes, but you don't know where it is. So it's really difficult sometimes, or time consuming, that to find the actual error, because you don't know where it's happening. You have to find it. And also sometimes it cannot guarantee that your software is working fine. Maybe let's say you have a software that is really complicated. You will test some parts but not the all parts. So it means it cannot guarantee that it has a full coverage of all your part of your softwares. So these are the important parts. But the best practice is using static analysis and dynamic analysis all together. Let's talk about two of these tools, that that is being used for memory-related problems in dynamic analysis. What do I mean by that? For example, sometimes your software not working from the memory parts, and there are some tools. Of course, sometimes you run it and you see it's using too much RAM. But there are some specific tools that analyze your software, your program, that if it is using right amount of memory or no. Let me show you, for example, one of them. Let's say Dr. Memory. There are many tools, but let me show you Dr. Memory. I will go to Windows. Let me show you. For example, here I have installed it. You can simply go to just simple download. Let me download Dr. Memory. And this is the website. You go and it has version. You go to download part and simply download it. It has both for Windows and Linux. So let me close it. Okay. I have installed it on my Windows, and I want to show you an example of it. So I will go to my, let's say, program files, and I want to do a memory check, memory analysis for a software in a real life. I will go, let's say, on Notepad++. Let's say there's a software, because I don't have much on my Windows, and this is Notepad++. I'm assuming you have already installed Dr. Memory, and it's here. It's simply, the simplest way, you can even integrate it to your Visual Studio. I already did it. Let me let me show you my Visual Studio. You can even integrate Docker memory inside your Visual Studio. You can. I don't want to go to that, but on the website it says how to integrate it. Oh my God! Integrate these two together. Okay, and but I want to go you. I want to show you the classical way. Let me go to. Let me minimize it. And so you are here. You have here Docker memory, and you have a software. You simply drag it to Docker memory. I'm not going to talk about Docker memory. I'm just going to show you a dynamic analysis practice. So it it tests your software in memory related aspects, and it gives you some report. It gives you that, okay, it might take a while, but it shows you that, okay, for example, your software using this part of memory, this part of, and it runs your software. Let me close it and let it be finished just for a while. Okay, see, it creates a report automatically, and it, for example, shows errors found here at the end that, for example, you will have this amount of uninitialized access. You have, for example, invalid heap argument, but for this program is 0. I just want to show you, for example, this is just one practice of dynamic analysis. Sometimes you don't use Docker memory. You just run your software. Let's say Notepad++ is your software. You run it and you test it, you click on everywhere and you do this and you that, and you see if it crashes or not. So dynamic analysis actually is running your code and see if it's working fine or no. I just showed you one example of memory-related dynamic testing. So the main important two parts is covered, which is static and dynamic testing. So let's talk about white box testing. It is actually a concept. It's not a new thing. I already told it in other things, but let's review this concept. White box testing, it has even different names: clear box testing, open box testing, glass box testing. It means a tester, which is you or your colleague, knows how your software works internally, knows the structure inside your software, and he or she is testing it. So it's like your software is like a box that its inside is clear, and your tester is checking that if this input go in a right way inside your program and processed in the middle in the right way and generates the output in the right way. It's like looking at a human from X-ray. You see for example, what he's doing, but you see inside how his heart is doing, how his liver is doing, and so on. So it's a concept. The other concept is black box testing. Black box testing, also known as behavioral testing, means you don't know what is inside. You don't know what is inside. You just give it some input and you want output. And you see if it's doing right or no. Let's say you're having a Word to PDF software, right? You just give it a PDF, a Word file, and you just get an output file, which is PDF. If it's working fine, so the black box testing is passed well. So that's all. Why it's called black box? Because you don't care. Unlike the white box, you don't care what is inside. You just give input and you want output. That's it. Visual testing or GUI testing. Actually, you are testing your software from the GUI aspect. You are seeing, for example, each button, each window. If you click on this button, if you click on that window, the graphical user interface is working fine or no. So actually you are testing. So it basically you already know it, but I'm just telling you that it has a like a, let's say, term in software engineering, and this method of testing all the button only visual parts called visual testing or GUI testing. So that's it, pretty simple. So we have some test levels. Okay, I will explain what do I mean by test levels. Up until now, I was talking about test types, that you have different types: static testing, dynamic testing, white box testing. But now test levels, it means on how deep you are going to inside your software to test each elements. So basically, you already heard that I have repeated unit testing over and over. I say, okay, I will talk about unit testing, unit testing. So unit testing is, I will explain it in the next slide. Actually, all of them are kind of unit testing, but each of them in different scale. So it means like you have a unit. What do I mean by unit? It's like, for example, in next slide I will explain. And then you want to work this part. Let's talk about, let's make it synonym to the part. So you have some part in your software and you want to see if this part is working fine or no. You have a component in your software and you want to see if this component working fine or no. Or integration test, system test, acceptance, alpha and beta. I will talk about them. I will talk about these more briefly, but I will go deeper on the unit testing. Okay, let's talk about it. So unit test, why we do unit test? In software, you have different functions, you have different code, different lines, you have different classes, and you want to test the smallest part or smallest functions, that to make sure if this function is working fine, if this class is working fine. So this unit can be that function. This unit can be that class. So unit is basically the term. So as I said, it's just like metric units. You have gram, kilogram for mass. You have centimeter, meter. So in software engineering, you have function, you have classes, or you have lines of codes that sometimes these units are packed together, and sometimes it's just a single function, and you want to test it. Okay. I will show it to you in real practice, and you will see it later. So let's. I already told you that you can test a function with unit testings. What do I mean by that? Let's see. Let's simply see. Okay, let's say we have a code which is simulating Morse code for us. Well, I assume you know what is Morse code, but let's for those of you who don't know, Morse code is something that is used in, let's say, many years ago, that you might see in movies, that like in telegraphs, they would put, okay. There was some, for example, did some kind of this. It can be they transferred some message via dots and dashes. So it means, for example, a letter A would be a dot and dashes. A dash would be, for example, a dot would be like a small beep. A dash was long beep, and they send it via a telegram or via, I don't know, any kind of transferring, let's say, medium, and it was something that was used back in times. So and each letter has a specific series of dots and dashes, like did or did, something like that. So I just wanted to show you what is the Morse code, and we have a software, we have a code now that is mimicking, simulating, let's say, this Morse code for us. So this is, I already prepared it because I don't want to talk about programming. Actually, I want to talk about testing this software. right? So let me explain it briefly to you how this software works. I already showed you that each character has a dot and dashes, right? So we have a function actually that gets a letter like A, B, C, D, and each of them has specific characters. How do I know which? We don't care now, but it's according to the map I already showed you in Morse code map. Okay, so assume we have a map and we know what is B, what is C, what is D, and so on. So this function is actually transferring each letter to its Morse code. Okay, and then we have another function that gives a string and send it to this function which I already explained. And because the first function is only about the letters A, B, C, D, but when we have a message is series of letters, right? So it's like, for example, SOS. It's like hello. So it's actually transfer a sentence to this sends a letter sentence to these functions and receives its equivalent Morse code. So basically, those are our two functions, and this is like a main functions. For example, we have a string, and let's say it's like welcome, okay, and we have a let's say we want, for example, send this welcome to our Morse code, which function is just I already explained to you, and it gives us its Morse code and it shows for us. So let me run it at first so you will understand how it's look like. So it's welcome. Actually, I'm sending welcome, and I want to see get the echo. You see, for example, the first dot dash dash is W welcome. In like if it was back in times and I could send it by sound, it would be its equivalent Morse code. So this is it, right? So I'm not going to talk about Morse code. I just wanted you to understand, so then you can understand what I'm going to test. So assume that I'm going to test my software using what? Unit tests. So I have a function here and I want to test it, right? So let me write a unit test. What do I mean? It's simply just a function that is going to test other functions. So I will say unit test. This is optional, of course. And I will write a function. For example, void. Let's name it something. Test my Morse. Just simple like that. Okay. And I open it. Okay. How do I want to test something? I give a message that I already know what would be the result. For example, I would put like a string S, and let's say it's SOS. I know this message. Okay. Then I know that this SOS is equivalent to, let's say, let me put it result. I would say the SOS according to this map here, like S is 3 dot and O is 3 dash. Okay, so basically then it should be dot 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 S dash 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 dot dot dot. So it should be SOS. Okay. Now I want to transfer this using my function and see if it's equivalent to this or no. What do I mean by that? I mean, for example, I will have let's say a string, and I call it Morse. It means I'm going to transfer it to Morse, and I'm going to use my function. My function is Morse code, right? Okay, let me see. Yeah, let me put it here, like at the end of all functions. Okay, so I'm using this function, You see this, I'm going to test this function. So I'm going to send this S here. Okay, so this S Morse will be the equivalent Morse code of this S. And I want to check if this would be similar to this or no. So I will check, I will put an if that S Morse, sorry, if that S Morse is similar to result, so it means the Morse code equivalent of this is similar to this. So it means my software works well, right? That it generates exactly what I wanted. So it means that it works fine. As I would say, C out. I would put match and OK, whatever you want. And then I will put an end line. Okay. So that's it. So basically, these unit tests is testing. It can be anything that you want. You know, I want to know if my function working, producing this result and working fine or no. Okay, so that's called writing a unit test, basically. So let me test it now. Here, I will call what was the name of my function? What did I name it? Test my Morse. Okay, I will put like test my Morse here. So let's see if this function works fine. It should be print match and OK. So let's see. Match and OK. It means that this SOS, which used my function, producing something here, which is exactly just like this result, which is equivalent of the SOS. So this unit testing actually is simply just like that. It means you are making something that let's say that you are making a function, or you are making a unit that testing one unit in your software. In this case, I was testing this function. So, and I understood it is working fine. So writing unit tests basically is like that. Okay. But well, now that we are here, let's talk about debug as well, right? In Visual, debug is, as I already said, I think you already worked with it in your C# course, but I will then that's why I will just talk about it briefly. So basically, debugging means like going through your code and see if it's working fine or no, right? And see your variables if they are expected as you want or no. So in Visual Studio, you can define something which is called breakpoint. Okay, so breakpoint means that if I just simply click somewhere, I will click here, and it created like a red dot for me. It means when my computer goes through these lines from above to here, it will stop here, and then I can say continue. So it's just like a focus point that my software will stop, and I can check the variables if they are working fine or not. Let's try it. That's it. I will put debug. You see, my software came here, my code, and it said that it stopped here. And in watch area, okay, let me delete it. Okay, here when you put debug and it stops here, you in watch area you can define some variables and you can see how the value inside these variables is. For example, you see S, right? I put S here in watch and enter. You see, it shows that the value inside is SOS. Or I will put results, let's say. Results. It shows it. So if sometimes my software or my code not working well, and I am expecting here, let's say my software is working SOS, but it's not having SOS here. And I can see, okay, then it doesn't have proper value. So it shows me that I can monitor my code and my variable using debugs. As you see this yellow arrow here, I can move it up and down. You see, it means like now, sorry, it means that now my code will start from here. So you can, like now in the eye of Visual Studio, it will be run from here. So let me continue. See, again, it stopped at my breakpoint. If I put continue, okay, it arrived here, let's say, okay? So, and I put continue, let's say access violation, for example, something. So I think I changed something here, but I don't want to talk about that because it was working fine. So and if you click on this breakpoint again, it will go away. So you put breakpoint and your software goes here and stopped here, then you continue and you can remove it. So now I go to debug and I stop debugging. Okay. And so let me remove this. Oh, it says I have an error here because I forgot to put, I removed the semicolon here. Okay. So now it's gone. Okay. So also, for example, debugger can shows you if you have some error. For example, let me run it again. So we know that our unit test works fine. Now, by purpose, I want to put some error on my own wheel. So I will put, for example, I will define, let's say, int a. So that's it. And then I will put, for example, let's say a is equal to 8 divided by 0, right? So it's like by you know, in computer you cannot well, you studied already C++. I know you understand this, but I just wanted to show you in the term of debugger. So if when I now debug here, it will produce some error. I just want to show you the debugger. So let's find and give that error. Says it makes some errors. Would you like continue and run the last successful bit? I say no. And then it will move me to my error list. You see, you had output and you have error list. And if I click here, it goes here. You see this cursor here and say you have a divide by 0. So basically, as you see, you already know that in this way, the debugger will help us to find our errors. So that's it. And I will remove it and it's fine. So if I, for example, let's put a breakpoint here and run it again. So it should come here and stop here. So it's now here because the yellow arrow is here. And if I press continue, it continued the rest. You see, it continued. So that's it. I'm not going to talk about programming. I just wanted to talk about unit tests and how it can help you to check the functionality here, to check the functionality of your code. Okay, let's go back to the our presentation. So basically, you already know what is unit tests. You see, for example, this is the structure of unit test for later if you want to see. So basically, let's say we have a sum functions that is going to plus two variables together, right? So it's a sum, like a plus b. How would be the unit test for it? Basically, you arrange, act, assert. Okay, simply you arrange it. Well, these are just terms for you to remember. I want to test this a plus b, right? So I will put like first value, for example, 100, second value 200. Then I know a result that would be like, for example, some of these, I will use this function. Okay, so this function, I'm going to send this first value and second value and use this function and put it in result. Then I'm going to compare this result, okay, with the sum of these two variables. So it means if this sum is equal to this sum, means my function is working well. I already showed to you if this SOS is which is gathered from this function is equal to this, it means it's working fine, just like the sum function. So basically, you are testing your functions, and with the expected value, if it's working fine, you say, okay, my unit test is working fine. So that's it. Sometimes I will go to this briefly. I know you already heard a lot. Sometimes you want to test external sides of your software. For example, sometimes your software is going to use, let's say, Facebook, is going to use Google, is going to use other websites, library, APIs, okay? And you cannot connect to the real Facebook, you cannot connect to the Google while you are testing, you're writing your code. So there are some things called test doubles that makes these external things for you, so you can be sure that your software is accessing them right or no. I will show you with example and you will see. For example, there are three things that we have: mocks, fakes, and stops. I just want you to know these concepts. These are not something complicated, and I don't want to go deep inside it, but I want just you to hear it and know it. What is mock? For example, I have a function, and this function is going to access Google. So this mock is something provided by my programming language. I don't know if it's Python or C#. They have their mocks as well. You don't have to write them. You just use them. So I'm using a mock, and this mock will mimic the Google for me, and my function, and it shows me that if my code is accessing this or no, right? So what do I mean by that? For example, it mimics Google, and let's say you are going to connect to Google. Instead of actual Google, okay, instead of actual Google, you will connect to mock, and mock is saying to you, okay, I'm hearing it, it's connecting to me properly. So you understand at least your software is connecting to something, because you don't have access to the Google itself. But this mock will show you that your software, your function is connecting to it. So that's basically a mock. Basically, it simulates an outsider for you. And sometimes, well, they're very similar. Don't get afraid. Sometimes you want to return a value, and for example, Google will return a value like 1, 0, or anything to you, and you want to react based on that returned value. Okay, so a stop is just like mock, but it returns a value, value you want to you. And now your functions, you can see how your functions will react according to the returned value. For example, you connect to the Google, and it simulates Google for you, and it returns failure to you. And your functions will react based on failure. It returns success to you. Your functions will react based on success for you. So don't get, let's say, don't get confused. It just simulates you and shows you if your code is connecting to something externally successfully or no. The last thing is fakes. So let me give you, don't make it complicated. I'm going to give you an example. Fakes, it's like that. Imagine your function is going to handle a database with 1,000 records. Okay? So instead, and this database is somewhere on internet. Instead of connecting to somewhere in internet and getting the data, which is time consuming, it generates in a fake way these, let's say, I don't know, 10,000 records for you, and you will see if your software can handle this amount of data or no, right? So instead of connecting to internet and the actual data, it fakes the equivalent amount of data for you, and you can test your software. So that's fakes. So I'm going to these briefly, and we will finish the class. So component testing, it's like instead of unit testing, which is just like one function, which is just like small part of your software, you will test a component in your software. Like, I mean, we are looking a bigger scale. Like, for example, I don't know, like a big module of your software, if it's working right or no. Integrated testing, assume that your software has different parts and you were developing them separately. For example, one of your teams were working on this side, the other teams were working on the other side. Now you put all of them together, you integrate them, and you check if they are working fine together or no. I understand. Logically, you are doing them before even knowing what is integration testing is. But now you know the term. System testing. Still, you are testing the whole complete project as a whole system. So it's just bigger a scale of you are working the functionality of all your software, if it's doing the requirements well or no. So it's bigger scale. You have acceptance testing. Acceptance testing is just like a term that you give your software, for example, to customers, and if you see this software is accepted by your customer or no, if it's acceptable or no. So it's called acceptance testing. Alpha testing, it means like you are simulating the usage of your customers, your potential customers inside your teams. For example, you will saying, okay, now my program, my software is done, and now you are testing it from the eye of a customer that, okay, this part is working well or this part is not working well. So it's before releasing your software and you doing it. So that's it, called like alpha version of your software. Then we have beta testing. I just want you to know them. It's not something like really difficult and really with details. Beta testing, you definitely hear it. For example, some software has beta versions. It means you have a limited audience and you give your software to them and they will work with it and they will see, okay, if it's working fine, if it's have some crashes. It's like beta version of Windows, exactly like that. Beta version of a game, it's exactly like that. So if you just as a sample, you give your software to some customers and see the results. So, and with a funny meme, I wanted to finish this part. You see, for example, you have a developer, but your tester sometimes can handle it. But in real life, your client is not a special, let's say, it's not sophisticated person. So the real result at beta testing is when that your, let's say, your potential customers can work for it, not your tester. So that's it for now. And this part is finished. The things that were, I'm going to review what we have learned. We have learned what is static testing is. we have learned what is dynamic testing is, and we have learned what is unit testing is. Okay, like in your project, for example, I might ask you, like, how did you do your, let's say, static testing? For example, you might say, I was using built-in Microsoft analyst part for analyzing my code, right? So for example, if I said, did you use any unit test in your software? You say yes. For example, I had a function and I called it like that and I tested it like that. That's called unit testing, right? So the important part was static testings, knowing these concepts, what is unit testing is, that you have some automatic tools to test your, let's say, memory, you have automatic tools to test your codes and so on. So that's about this course. Before I talk about the projects, your final projects, do you have any question about this week and this testing and debugging part? I'm ready to hear.
No,
No,
thank
sir,
you.
thank you.
You're very welcome.
Thank you so much.
You're very welcome. So